We have learned previously that you can store all sorts of data in memory, including numbers, text, or pretty much anything you want. We have learned that to store anything, you have to specify its size using certain keywords like short or long, etc., and specifying its data format using keywords like int or char, and so on. We have also learned that every programming language gives you the ability to give simple, plain English names to any data that you store in memory. Now we need to take this knowledge to the next level. Whenever you create data and give it a simple name, that is usually called a variable. For example, I might tell my programming language that I want some data to be an integer, and that I want to call that data total, and that I wish to assign it some value such as 5. I have now created a variable. Now let's suppose I want to do exactly this. First of all, what kind of data type do I want? Well, it is a small number and it is positive, so a short, unsigned int makes perfect sense. Now I have to give it a name. I will call it total. Now I have to give it some value. Here is how I do all of these steps. And here you see how to do that. I specify that this is going to be a short, unsigned integer. I'm giving it a name. In this case, I'm calling it total, and I'm assigning it the value of 5. So here are a few questions you need to be able to answer along with their answers. First of all, what is the variable's name? The answer is total. What is the data type for this variable? The answer is unsigned short int. And the third question is, can negative numbers be stored in this variable? And the answer is no, because it is unsigned. If you have been following all of the lessons up until now well enough, you should be able to understand how this variable actually looks in binary stored in memory. We know that it is 2 bytes long, that is 16 bits. We know that the binary for the number 5 is 0101. If we assume that this variable would take up 2 bytes, then it would look like this in memory. Now, notice all of the unused space. Because 2 bytes can hold up to 65,536 values, there is a lot of wasted space. I want to explain a few important facts concerning variables. Since I have assigned this variable 2 bytes, it will always contain 16 bits. These 16 bits will always be understood to be a number between 0 and 65,535. If I perform some mathematical operation that results in a number greater than 65,535, then, as we have seen in earlier lessons, the result will be a wrong answer because no value that big can fit in 16 bits. Always remember this. From the time you create a variable through to the end of the program, it will always be limited to the size you gave it, and it will always be understood to have the data type and format that it had when it was first created. Please be aware that unsigned short int is not required to always take up exactly 2 bytes. This, as well as the size of data types in general, may differ among C compilers. In this lesson, I used 2 bytes to illustrate the material presented.